Okay, hello everybody. I'm going to start off with lesson 6. We're doing 6.1 function operations. You have done this in the past, but we're going to go through it again today. So operation with functions, we do need to be a little careful. When we're operating with functions, the domain consists of all values common to both the domains of f of x and g of x. So basically, any functions that we combine together, we have to be cognizant of the domains of both functions. And then we also need to be careful that when we're dividing, when we're doing a quotient, we're excluding anything that's going to make that denominator 0, because dividing by 0 would give us something that is undefined. So we can do a couple of different operations that we're going to talk about today. With functions, we can do the sum. So that's where we just add two functions together, and when we add two separate functions together, we make just one complete one. We can also subtract, we can multiply, and we can divide. But again, with that division, we need to be careful that that denominator is not equal to 0. So we can also do what's called a composition of a function. So that's this here. And this is representing f of g of x. So it's taking one function and plugging it into another. And we'll do some practice with that a little bit later. So the first thing we're going to do is we're going to do this with a table. And it's asking us to use this graph in order to find each function. So f plus g of 1 is really representing f of 1 plus g of 1. Okay, so we can kind of split it up because we know what each of those individual values are, but we may not know what they are together. So then we go to our picture. And so if we're looking at our picture, we look at the x value of 1, and then we look at the graph of f, and we see that it's leading us to this point. So that means f of 1 is negative 1. And we do the same with g. We're trying to find g of 1, so we'd go to the x value of 1, then we'd look at the graph of g. So g of 1 is this point up here. That point is 2. So we're really doing negative 1 plus 2. And so f plus g of 1 would just be 1. We'd repeat that same thing with the next one. So again, we can split this up to be f of 2 minus g of 2. These are the same thing. So this time we're going to go over to the x value of 2, and we want to figure out what the value for f is. So we'd look at the graph of f, that brings us here. That value is 1. So that means f of 2 would be 1. And then we'd find g of 2. So again, we'd go over to 2 in the x direction, and we'd look at g in the y direction. So we see that that's also 2. So we'd say negative 1 minus 2. That's going to give us negative 1. Okay, we can also do this with multiplication. So f times g of negative 2 would be f of negative 2 times g of negative 2. So this time we're going to negative 2 in the x direction. You do need to be careful because sometimes, like we see here, our graphs switch from being on top to being on bottom. So we need to be careful with that. So at negative 2, f of negative 2 is actually the upper function, and that value is 2. So f of negative 2 is 2. And then we'd say, okay, g of negative 2. So can we go over to negative 2 in the x direction and find the graph of g, which is here. And that value is a positive 1. So we're doing 2 times 1. And so that means f times g of negative 2 would be a positive 2. Okay, so then we can also do division. So we'd split this up and we can say this is f of negative 1 over g of negative 1. So we'd look at negative 1 in the x direction. And f of negative 1 there is actually 0. So we'll put 0. And we still do need to find g of negative 1, and that value is 1. You see that here. So 0 over 1 is actually fine to have. It just means that it's going to be 0. Okay, so again, we can split this up again. We'd say f of 0 over g of 0. So we'd look at 0 in the x direction, and f of 0 is actually negative 1 here. And g of 0 is actually 0. Is this allowed? No, it's not. This would be considered undefined. So there isn't actually a value. It doesn't actually work here. Okay, and then we can also do this. This is again called a composition. So this is representing f of g of negative 2. So what that means is we work from the inside to the outside. So we want to first start by finding g of -2. So we go over to our graph and we can say, okay, -2, what is g at -2? It's 1. So again, we just found that g of -2 is 1. So I can take that 1 and I can plug it in. So now instead of finding f of g of -2, I'm really just finding f of 1, which is a little bit easier to work with. So we look at 1, and f of 1 is -1. We see that here. Okay. And again, we can also kind of go the other direction. So this represents me looking for g of f of 1. So again, I'd start by the inside. I'd first start by finding f of 1. So I'd go over to my graph and I'd look, okay, f of 1 is -1. So instead of finding this big funky thing, this g of f of 1, I'm now just looking for g of -1 because that's what f of 1 gave me out. So then I'd go over to my graph and I'd find -1. G of -1 is 1. Okay. And so that is a composition. We did do some of those last year. Okay, so we are going to find the following composition, or find the following operations, and we're going to give the domain on all of these but the composition. So in order to give the domain, we first have to establish what the domain of each of these are. So things that would change our domain are like radicals or fractions or things like that. So both of these graphs are actually linear, which means both of their domains are going to be -infinity to infinity, which makes our life easier when we're doing these operations. So if we're looking for f plus g, then literally all I'm looking to do is take the equation f, this x plus 10, and add g to it. So I'm adding this x minus 5 to it. And then I'm simplifying. So I can combine those two x's together to get 2x, and I can combine 10 and -5 to get 5. So this would be my new function. And again, I do need to state the domain. So when we're talking domain, we're talking the most restricted domain possible, but because both of the original functions are -infinity to infinity, this domain would also be -infinity to infinity. Okay? And so then we can again do the same thing, but this time with subtraction. So this time I'm doing x plus 10, that f function, minus, and we do need to be careful here because we do need to put parentheses around that second function. Okay, we need to be really careful with subtraction because I do need to distribute that negative out. So this is going to give me x plus 10 minus x plus 5. Okay, so when I combine those two x's together, they're going to go away, and I'm just going to end up with 15. That's okay, we're allowed to get a number out. Again, the domain would be the most restricted one, and that's going to be -infinity to infinity. We're allowed to have that. Okay. The next one we're doing multiplication. So we're taking these two and we're doing x plus 10 times x minus 5. And if you realize that we need to do the box here, good job, you're correct, we do. So we do x plus 10 times x minus 5. X times x is x squared. X times 10 is 10x. X times -5 is -5x. And -5 times 10 is -50. So we can take out an x squared. We can combine the 10x and the -5x to give us a positive 5x. And then we just get -50. Again, both the domains are -infinity to infinity, so that's the case for this as well. Okay, so for division, we're going to go ahead and we're just going to divide them. So we'll say x plus 10 over x minus 5. And these two actually don't simplify, right? These are not the same thing, so they're not going to cancel out. So we just kind of stop here for the function itself, but we do need to state the domain. And this is a scenario where the domain is actually restricted because, again, that denominator cannot equal 0. So in this scenario, it's going to be everything, because when we set it equal to 0 and solve, we'll get that x cannot equal 5. So it'll be everything except for 5, which you can write as x cannot equal 5, or we could also write as -infinity to 5 union 5 to infinity with parentheses. So the reason I do both is just depending on what the question asks for, whether it asks for an interval notation or not. Okay, So again, the next one is looking for us to do f of g of x. Okay, so that means we're taking that g equation um, and we are plugging it into the other one wherever we see an x. So really what we're doing is we're doing f of x minus 5, which is that g equation. Okay, so we see that f equation is x plus 10. So we're going to replace that original x with this other function, this x minus 5. So this would be equal to x minus 5, that's me replacing that x, and then plus 10. Okay, so stare at that for a second if you need to. But I just took the equation g, that x minus 5, and I plugged it into the other one. And so then we can simplify this, and this should turn out to be x plus 5, because we can combine those like terms. Now, for these, the domains start to get a little more complicated, so that's why we don't need to include the domains on compositions. It also told us in the direction, so I'm not going to put that. So then we would have to go to the other way. So now we're trying to find g of f of x. Okay, so now I'm taking this equation, this f of x, this one, and I'm plugging it in for x in the other equation. So I'm really finding g of x plus 10. Okay, so I'm going to plug that in. So that would be x plus 10 minus 5. So let me try to highlight. So again, this is that x plus 10. This is that function. And I plugged it into g for x. So that's what this is representing. That's representing me plugging it in. And so we can again simplify this, and we're going to get x plus 5 again. Now, these two are not always the same thing, so we do need to be careful about it, but they can be. Okay, going on to the next one. Okay, so the next one, again, we need to think about these two functions, and we need to say, okay, what kind of functions are they? And so therefore, what is their domain? So looking at the first one, that's a parabola. And we know that for domains of parabolas, that's going to be negative infinity to infinity. And the second one, again, is a linear. So we also know that is going to be negative infinity to infinity. Okay. So again, we're doing f plus g. I'm actually going to try to highlight this time. So I'm going to make f in this color, and I'll make g in pink. So we can kind of see what I'm doing here. So, and then I'm just going to pick a normal color. Okay. So f plus g, we would say x squared minus 2x plus 3x minus 4. We're again just adding these two functions. So we're taking the first function and we are adding that second function. So then we can combine our like terms. So that would give us x squared. We'll combine that negative 2x and that 3x to give us just a plain old x, and then minus 4. Again, both the domains are negative infinity to infinity, so this one would be that as well. Okay, so for the next one, again, we're subtracting, and we need to be careful that we're putting a negative around that second function. So I'm doing f minus g of x. Okay. So now I am going to need to distribute that negative out. Oh, didn't mean to do that. I'm going to distribute that negative out. So I'm going to get x squared minus 2x minus 3x plus 4. And then again, I'm going to combine my like terms. So that's going to give me x squared minus 5x plus 4. And you don't need to factor or do anything. This one actually does factor, but you don't need to go that far. I'm just asking us to simplify. So then again, we want to write our domain, and our most restricted domain would be negative infinity to infinity. The next one we're doing is multiplication. So we do x squared minus 2x times 3x minus 4. Okay, and we, again, because of these terms, are going to need to use the box for this one. Okay, so x squared times 3x is 3x to the third. 3x times negative 2x is negative 6x squared. X squared times negative 4 is negative 4x squared. And negative 2x times negative 4 is a positive 8x. So we would take this out and we would get 3x to the third. We can combine those x squareds to give us negative 10x squared and plus 8x. And again, our domain is negative infinity to infinity. Okay. So then we would do division. So again, we're taking f, which is x squared minus 2x, and dividing by g, which is 3x minus 4. F by g. Okay. We do want to factor both things to see if anything is going to kind of like cancel out or anything for us. So we should hopefully notice that in that numerator, we can take out an x. So that's going to be x times x minus 2. And it's over. That denominator doesn't really factor. So nothing is going to cancel. So we need to think about, okay, that denominator cannot be equal to 0 here. So we'd set 3x minus 4 cannot equal 0. And we'd have to solve that. So we'd add 4 and divide by 3. So we'd get that x cannot equal 4/3. But I am going to write that in interval notation. That would be negative infinity to 4/3 union 4/3 to infinity. Okay. So the next one, again, we're doing f of g of x. So that means into f of x, we're plugging in g of x. So we're really taking f of 3x minus 4. Okay, so we should see that f is x squared minus 2x. So in for that first x squared, we're going to put 3x minus 4. So that 3x minus 4 is representing g, but that something squared, that like x squared, is what we're plugging in. So this is representing that x squared. I'm just substituting 3x minus 4 in for x. Okay, and then we're doing minus 2 x. So again, I'm going to put that 3x minus 4 in there. So again, that minus 2 is part of that f equation, but we're plugging in 3x minus 4 every time we see an x in that original equation. Okay, so now we may look at this and you say, okay, we're doing 3x minus 4 squared. We are going to have to do the box for that one. So we're doing 3x minus 4 times 3x minus 4. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. We'll get another negative 12x. And negative 4 times negative 4 is 16. So that means this first piece is going to become 9x squared minus 24x plus 16. And then we do also need to distribute that negative 2 out. So we'd say minus 6x plus 8. So then our last step is just to combine like terms. So we'll get 9x squared. We can combine that negative 24x with that negative 6x to get negative 30x. And we'll combine 16 with 8 to get 24. Again, we do not need to state the domains for these, so we can keep going. Okay, so this next one is asking us to do g of f of x. That means into g, we're plugging in x squared minus 2x. We're plugging in that f equation. Okay, so everywhere we see an x in g, so up here, every time we see an x, like right here, we're substituting in that other equation. So this would be 3, that's from that g equation, times x squared minus 2x, again, we're plugging that in for x, minus 4. So that x squared minus 2x is what we're plugging in, but the rest of that 3 and that minus 4 is all from that original g equation. So the only thing we're changing is x there. Okay, so then we would distribute out the 3. So we'd get 3x squared minus 6x minus 4. And again, we don't need to state the domain here. Alrighty, moving on to the next one. Okay, so before we go ahead and get started, we again need to think about, okay, what is the domain? So looking at that numerator, at that top one, that is a linear. And so that one has a nice domain of just negative infinity to infinity. The denominator is where we need to be careful. So what do we know about radicals? Well, radicals, whatever's under the radicand, needs to be greater than or equal to 0. Because when we take the square root of a negative number, that's when we start to get imaginary. So we need that 9 minus x squared to be greater than or equal to 0. So we would need to factor that. So this we would factor by difference of squareds. So the square root of the first number is 3, and the square root of x squared is x. So we do 3 plus x, 3 minus x. And we need that to be greater than or equal to 0. So we can think about this kind of graphically. This would be a parabola that opens down. Its zeros would be negative 3 and positive 3. So again, we have a parabola that's opening down. We know it's opening down because of this negative in front of the x squared. So this is a parabola opening down. So if we think this part of the graph is negative, this part of the graph is positive, and this part of the graph is negative, and we have closed circles on each of these because it is or equal to, which one would we want? We would want the positive one, right? We want something greater than or equal to 0. So that means the only interval that works for this one is from negative 3 with a bracket, again, because those are closed circles, to 3 with a bracket. So again, we take that piece, it's got to be greater than or equal to 0. We'd factor it. We'd draw a little sketch of it in order to find the domain. Okay. So again, I'm going to call this F, and I'm going to call this G. So again, we're setting this up. We do F plus G. So I do x minus 4 plus the square root of 9 minus x squared. And that actually doesn't simplify, right? One part of it's a square root, and one part of it is not. And so because of that, we actually have to leave it as is, and that would be our answer. But then we have to think about domain. So for domain, again, it has to be the most restricted domain possible. And between these two, the most restrictive domain is going to be the bottom one, right? Because the other one is just infinity, negative infinity to infinity, whereas this one actually has some restrictions going on. So our domain for this is actually going to be negative 3 to 3, because that is the more restricted of the two. Okay, and then we would do subtraction. So we would do x minus 4 minus, parentheses, the square root of 9 minus x squared. And I can't really distribute out a negative into a radical because the radical is kind of protecting everything under it. So really, this looks just like this because that radical doesn't allow it to be distributed. So that would be our answer. And again, we're going with the most restricted domain of negative 3 to 3. Okay, so then we would do multiplication. So we would do x minus 4 times the square root of 9 minus x squared. We actually don't need to do the box for this. There isn't a ton that we can do with this, but we can distribute out both of these pieces to that radical. So that would look like x times the square root of 9 minus x squared minus 4 times the square root of 9 minus x squared. We can't really multiply it out any more than that because we can't multiply outside of the radical with inside of the radical. And again, domain would be the most restricted of negative 3 to 3. Okay. Then we would do division. So we would say, okay, f, which is x minus 4, over the square root of 9 minus x squared. So again, we can't really simplify it any further than that. But we do need to think about the domain. So for this one, the domain, that denominator can't be equal to 0. And so that would change for this specific problem, those closed circles to open ones. So we would still be working with a similar domain, but it would be parentheses -3 to 3 this time, because that denominator cannot be 0. Okay. So for the next one, so now we're doing a composition. So this time again, we're doing f of g of x. So that means into f, we're plugging in the square root of 9 minus x squared. Okay, so we're plugging in that g equation. So that means everywhere we see an x in that f equation, like right here, we're taking the other one and we're plugging it in. So we see x, so we'll put square root of 9 minus x squared in for that, minus 4. So again, this is representing that g that we're plugging in, and this is representing the original function. So we can't really distribute anything, but we can just drop those parentheses. So this would be 9 minus x squared minus 4. And we leave it like that. Can't really do much more than that. So then the next one, we're doing g of f of x. So into g, we're plugging in x minus 4. So this is that f equation. So everywhere we see an x in that g equation, which is right here, we're going to plug in the other one. So this is equal to the square root of 9, that's not changing, minus, and then instead of x squared, we're putting x minus 4 squared, that other equation. Okay. Again, if you are looking at this and you're like, oh my god, we're going to have to do the box again, you're totally correct. We are going to have to do the box again. So we're looking at this one, we're going to do the box for that x minus 4 squared. So that's going to be x minus 4 times x minus 4. So x times x is x squared, x times -4 is -4x, x times -4 is -4x, and -4 times -4 is 16. So this is going to give us a square root of 9 minus parentheses. We get an x squared. We can combine those negative 4 x's to be -8x, and then we get plus 16. So then we do still need to distribute out this negative. So I'd get the square root of 9 minus x squared plus 8x minus 16. And lastly, we can combine that 9 and that negative 16 to get the square root of negative x squared plus 8x minus 7. And again, we don't have to state domain for that. Okay, moving on to the last big one. We're working with two fractions here. So the numerator one is, again, just really a linear, right? Denominators cannot be equal to 0, but we have just 2 in the denominator, so that's fine. So the domain for this is -infinity to infinity. Whereas in g, we have 4x in the denominator. So that means that 4x cannot equal 0, which means x cannot equal 0. And if we're writing that as an interval notation, we'd say -infinity to 0, union 0 to infinity. So everything except for that 0. So now we are going to start with some addition and subtraction. So when we're doing addition, we'd have x over 2 plus 3 over 4x. So for this one, we do need to get a common denominator in order for this to work. Okay. So we need to get a common denominator. So the least common denominator in this case would be 4x, which we already have in g. So what we need to do is we need to multiply that first piece by 2x over 2x in order to get a common denominator all the way through. So 2x times x is going to give us 2x squared in the numerator, and 2x times 2 would give us 4x in the denominator. So we're doing this plus 3 over 4x. And now because they have a common denominator, we can add those two numerators together. So we get 2x squared plus 3 all over 4x. And again, the most restrictive domain would be this one. So the domain for this would be -infinity to 0, union 0 to infinity. We do something similar with subtraction. So again, we have x over 2 minus 3 over 4x. So again, we're going to need to get a common denominator here. So we'll multiply that first piece by the same thing as last time, 2x over 2x. And again, that'll give us 2x squared in the numerator and 4x in the denominator. So minus 3 over 4x. And again, because they now have common denominators, we can just combine the numerators to be 2x squared minus 3 all over 4x. So again, the domain is going to be negative infinity to 0, union 0 to infinity. And then we can do f times g. And so what we would do there is we would say f, which is x over 2, times g, which is 3 over 4x. And we can actually just multiply straight across here. So we would do x times 3 in that numerator, which is going to give us 3x. And 2 times 4x in the denominator, which is going to give us 8x. We should hopefully see that those x's would end up canceling, and so our answer is really just 3/8. But we do still need to include that domain, which would be negative infinity to 0, union 0 to infinity. Again, still can't have that denominator divided by 0 because of those original functions. Okay. We can also do f divided by g of x. So the way that we would set this up is we would say f, which is x over 2, divided by g of x, which is 3 over 4x. And you may not remember it, but when we divide fractions, we can actually multiply by the reciprocal. So we can turn this into x over 2 times, we'll flip that bottom fraction and turn it into multiplication. So 4x over 3. So then we multiply straight across and we get 4x squared over 6. And both of those are actually divisible by 2, so we'd go ahead and divide them to get 2x squared over 3. So our domain would be negative infinity still to 0, union 0 to infinity. So even if, like in this problem or in the previous problem where we didn't have an x in our denominator anymore, even if that happens because those original functions did, we have to still include that as part of our domain. Okay, so next we're going to do f of g of x. F of g of x. So into f, we're plugging in 3 over 4x. That's what we're doing. So f is x over 2. So for that x in that numerator, we're plugging in 3 over 4x. So 3 over 4x, and that whole thing is over 2. So that 3 over 4x is what we're plugging in, and that over 2 is representing that f function. So again, we are technically speaking dividing two fractions because I can write 2 as 2 over 1. So like the last problem, I can turn this into multiplying by the reciprocal. So this would be 3 over 4x times, and we'd flip that fraction, so it'd be 1 over 2. So this would end up being 3 over 8x. And we don't need to state the domain here. We do the same thing going the other direction, g of f of x. So into g, we're plugging in x over 2 this time. Okay, so that's going to be 3, that's not changing, over 4 times x over 2. So again, that x over 2 is representing that f equation that we're plugging in, but everything else is representing g. So the nice thing here, though, is if we think about it, 4 times x over 2 would be 4x over 2, and 4 divided by 2 is 2. So really, this just turns into 3 over 2x, and we can stop there. Okay, so we got 2 more pieces. So we can also go the other direction. We can say find two functions such that h of x equals f of g of x. Neither function may be the identity function. So basically this means we're trying to find a composition. So we can go kind of the other direction. And there's more than one ways to do this. So we want to work on the inside. So we're looking to find an inner function. We'll call that g of x. So for example, we can say in this first example, g of x would equal the square root of 3x minus 7. Right, this whole thing I'm going to use to represent a function. So that would be like my inner function. And so then I would need to find my outer function. And so to find my outer function, I take that whole inner function, I'm going to replace it with x, and then I'm going to keep everything else the same. So it'd be x minus 4. So that would be one way to say it. Now there are more than one answer for these problems. For example, I could also say, let's say I didn't like that one and I wanted to pick something smaller or something different. Let's say I said that inner function is just 3x minus 7, this whole thing, right? So that's my inner function. So again, I'm going to replace that whole thing with just x. So then my outer function would be the square root of x minus 4. So there's even more options than that, but those are just two examples. Okay. I try to pick something pretty. So like for the next example, again, there's more than one answer. Let's say our inner function, our g of x, I picked to be this whole thing, this 2 over 4x minus 1. So then to find our outer function, I'd replace that whole thing with x, and it would be just x plus 3. So again, that's one option. Or another option, I could say, okay, maybe I don't want that whole thing. I just want this to be my inner function. So g of x would be 4x minus 1. And so then my outer function, my f of x, would be 2 over that whole thing. I'll replace it with x plus 3. And again, there's even more than that. This is just two examples. So last thing we're going to go through is those exponents that we need to know. We've done these before. We'll do them again. 2 squared, we should go 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 8, 27, 64, 125, 216, 343, and then it should be 512, 729, 1000, 1681, 256, 625, 32, and 64. Again, you guys should still know those, so please make sure that you remember them.